Kubernetes includes a set of basic API primitives that we'll interact with. The first 5 terms that we'll cover are node, pod, service, deployment, and replica set. I've already mentioned nodes when talking about the control plane, but more specifically, a node is a host machine, this could be physical or virtual, where your containerized processes are run. Activity on each node is managed by a kubelet process, which receives workload scheduling instructions from the control plane. Pods are a group of 1 or more co-located containers. If you wanted to launch a pod from the command line, you can run a command like kubectl create-f followed by the name of a local or a remote file in order to launch or provision a new group of containers on the cluster. This is an example of what a minimal pod spec might look like. You might notice a few of the attributes that I outlined in the previous slide. Kind is the type of resource that we're interacting with. API version is the versioned release of this particular API resource. Metadata includes information like creation timestamps, resource ID, and labels that can be used to select groups of objects. And the last 2 major fields are the spec and the status. Generally, you will set the spec on an API resource, and Kubernetes will do the work to fulfill and report back in the status area. This means that for each API resource, there's almost always 2 responses. The spec includes the requested resource state, and the status returns the actual resource state as currently known throughout the cluster. Pods will automatically do health checking for process 1 in each container. This means if the initial process fails, it's very easy for Kubernetes to restart it or restart the group of containers as a unit. Pods are scheduled to be run on nodes, and pods also represent your minimum increment of scale. If you have 2 web services that need to be scaled independently, they'll always need to be represented as 2 distinct and separate pods in the Kubernetes API, or 2 separate deployments, replica sets. We'll get into those topics next. Services are a Kubernetes resource that basically act as an internal load balancer, helping to spread traffic across a collection of pods. To create a new service or load balancer, you can use the kubectl expose command in order to provide access to the containerized workload. To see the results of this operation, try running kubectl get pods or kubectl get services. You can also use label selectors to list pods or delete pods in bulk. This example shows listing and deleting using -l run equals hello-k8s, which is a label selector that will identify all of our pods in the current group and delete those same pods using the same label selector. The last command deletes the service object that contains the ID hello-k8s. A service is basically an internal abstraction for a load balancer. The service resource uses label selectors to discover where traffic should be directed within the cluster. Label selectors can be used to organize workloads and to manage groups of related resources. Deployments are a specific resource type in Kubernetes. This means that the operation of delivering your software is now something that is entirely standardized and designed to help provide zero downtime while updating stateless applications. This kubectl run command example will generate a new deployment spec file. I'm including the --dry run and -o JSON flags in this example in order to output a new deployment spec file to standard out. I'm then redirecting the output into a file called deployment.json. You should be able to type cat deployment.json in order to review the output. This is what you should see in the resulting deployment spec file. As noted before, this resource file starts off with a kind of resource. It's internally typed. It's a versioned resource. In this example, we see it's versioned as apps/v1 beta1. There's a metadata field, including timestamps, resource IDs, and label selectors. And there's also a spec, including a replica count. This is a new attribute that we haven't seen yet. This particular specification attribute allows the collection of pods to quickly be scaled up and down by setting this value. There's another attribute inside the spec called template. This template includes a pod spec within the deployment spec. This pod spec is used whenever new pod resources need to be created on the API. Anytime the deployment spec, replica count, and the deployment status replica count are out of alignment, Kubernetes will automatically add more pods in order to get the two spec and status values back in alignment. This example shows how to create a new deployment based on the deployment JSON file that we created earlier. Running this operation should create the deployment resource and set its initial spec.replicas value to 1. The next example shows how to use kubectl expose to create a Kubernetes resource that exposes the hello K8s deployment using a node port type service. Including the --dry run and -o JSON flags helps allow this spec file to be outputted to standard out and then stored into a new file named service.json. You can review the service.json file to see what a raw service specification looks like. You can also run kubectl create -f on your resulting service.json file in order to expose the service based on a known specification. Leaving out the dry run and -o JSON flags in the initial command would essentially expose the deployment in a single command instead of creating the spec file as an intermediate step. This just shows you how to generate spec files on your own if you wanted to edit the raw JSON or YAML. Kubernetes and the OC command line tool both allow you to list multiple resources by type if you need to. Now's a good time to use the kubectl or OC get command to attempt to list pods, services, and deployments all in a single command. You can then connect, if you're running Minishift, this following command should allow you to connect to your remote environment and see if it answers.